Have you ever stopped to think about what's happening inside your computer right now? I mean, you're probably juggling a dozen tabs, maybe streaming some music, downloading a file. How does it not just, completely fall apart? Well, it's not magic. It's all thanks to a hidden, tireless manager working behind the scenes, your operating system. And today, we're going to pull back the curtain on this invisible genius that keeps our digital lives from spiraling into total chaos. So, to really get what your OS does, I want you to think about this question for a second. Seriously, what could a super stressed out restaurant manager possibly have in common with a bunch of code on your hard drive? The answer, it turns out, is the key to everything. That's right. At their core, they're both experts at stopping a very complex system from crashing and burning. So let's run with this. Think of your computer as this bustling, high-end restaurant. You're the customer, ready to order. The apps and programs are the chefs in the kitchen. And the operating system, that's the manager, running around making sure every single thing gets done right and fast without the whole place going up in flames. We're going to stick with this idea for our whole journey today. We'll look at the OS's job by breaking it down into three huge problems that every manager has to solve, whether they're dealing with chefs and waiters or with bits and bytes. First up, security. Okay, so what's job number one for any good restaurant manager? Keeping the place safe, right? You lock the doors at night, you protect your customers, you keep an eye out for trouble. Well, your OS has the exact same responsibility for your computer and all your data. This security promise really breaks down into three key parts. First, there's confidentiality. That's easy. It's like keeping customer secrets safe. Then you've got integrity. This means making sure the order you placed is the order you get. No one's messing with it. And finally, availability. This one's simple. The restaurant has to be open for business when you need it. Your OS is making these exact same promises for your digital life. And trust me, the manager is up against a lot. These are basically the digital versions of someone sneaking in after hours to use the kitchen, or a rival chef stealing your secret recipes, or someone changing orders on the way to the kitchen, or just blocking the front door so paying customers can't even get in. The OS has to guard all of this all the time. Now, this is where our restaurant analogy gets really useful, especially when we talk about these two troublemakers. A virus? Think of that like a single bad ingredient. It can't do anything on its own, but the second it gets mixed into a legitimate recipe, an existing program, it ruins the whole dish. A worm, on the other hand, that's a whole different beast. A worm is like a rowdy person who sneaks into the dining room and just starts running from table to table, causing chaos and disrupting the entire restaurant all by itself. So, how does our OS manager keep these unwanted guests out? Well, the first line of defense is authentication. The best way to think about this is like the bouncer at the front door. When you type in your password, that's the OS manager checking your ID, making sure you're on the guest list before it even lets you inside. All right, on to the next big challenge. So you're past the bouncer, you're in the restaurant. Now the manager's got to coordinate the pure chaos of the kitchen. You've got multiple chefs or programs all trying to use the same pots, pans, and stoves at the same time. You need rules or you'll have a disaster. This is what we call process synchronization. And this quote right here, it absolutely hits the nail on the head. Imagine two chefs trying to add salt to the same pot of soup at the exact same time without talking to each other. You're going to get inconsistent and, let's be honest, pretty disgusting soup. The same exact thing happens when two programs try to write to the same file at once. Your data just gets scrambled. To solve this, the OS manager has this one simple, incredibly powerful rule. It's called mutual exclusion. And in our kitchen, it's like saying, hey, only one chef gets to use the main stove at a time. It's a fundamental rule that prevents collisions and makes sure that shared things, like a file or a printer, get used in a nice, orderly way. This brings up one of the classic puzzles in all of computer science. Picture this. 5 philosophers are sitting at a round table with a big bowl of spaghetti in the middle. But there are only 5 chopsticks, one place between each person. Now, to eat, a philosopher needs 2 chopsticks. So the puzzle is, how do you create a system where everyone gets to eat and no one starves because they're stuck waiting for a chopstick? It's the perfect and kind of funny metaphor for managing limited resources. And that leads us perfectly into our third and final challenge. This is the OS manager's absolute worst nightmare. This is what happens when all that coordination and rulemaking fails so spectacularly that the entire system just stops. This is the deadlock. Now, for this total catastrophe to happen, 4 specific things have to go wrong all at the same time. Let's go back to our restaurant, but with waiters this time. 1. Mutual exclusion. Only one waiter can hold a specific salt shaker. 2. Hold and wait. A waiter is holding onto a pepper shaker but is waiting for the salt. 3. No preemption. You can't just snatch a shaker from another waiter's hand. And 4, the real kicker, circular wait. Waiter A needs waiter B's shaker, but waiter B needs waiter A's. They're stuck. So yeah, to put it simply, it's a complete and total gridlock. It's a digital standoff where everyone has something the other person needs, and nobody is willing to give up what they've got. Nothing moves forward, the whole system just freezes. We can actually see what this looks like using something called a resource allocation graph. In a healthy system, like you see here, the arrows show a clear, smooth flow. A process asks for something, gets it, uses it, and then lets it go. There are no loops, no circles. This is our kitchen working at peak efficiency. But look what happens here. A cycle has formed. A circle. Process 1 is waiting for something process 2 has, which is waiting for something process 3 has, which, you guessed it, is waiting for what process 1 is holding. That visual loop you're seeing, that is the deadlock. The kitchen has just ground to a complete and utter halt. So the OS manager's final and maybe most critical job is to be the ultimate traffic cop. It's constantly running strategies to prevent these cycles from ever forming or to spot them and break them apart if they do. But here's the catch. Being too careful can slow everything down. So the OS is always performing this incredible high-wire act, balancing the need for speed against the risk of a total system meltdown. It's an essential and really tough job. So, from security to keeping everyone in sync to preventing total gridlock, the operating system is this unsung hero, constantly managing an insane level of complexity just so we can have a smooth experience. Which kind of leaves us with one last big question. If the OS is this brilliant manager designed to prevent chaos, why do our computers still freeze up and crash? Maybe it's just a reminder of just how impossibly difficult its job really is.